So focus, attention. I want to try to get through your notes and give you as much work time as possible. So this is a function from yesterday. I went ahead and factored, and we decided that they shared a common factor in the numerator and the denominator, so we would have a whole. And remember, the whole is always going to occur at the 0 of that canceled factor, so -2. To get the y coordinate of the whole, you're looking at the factors that are left over, x squared minus 2 and x plus 1, and you're just plugging that x value in. So we also got another -2 right there. And then we did vertical asymptotes, set your denominator equal to 0. If the whole, if you have a whole, it's a whole and not a vertical asymptote. It's not both of the things. It's just the whole, not the vertical asymptote. Okay, so you have only one factor left over. X equals -2 is part of the whole. It's not another vertical asymptote. Let's see, we did horizontal asymptote yesterday. The degree of the numerator, of course, is greater than the degree of the denominator, so there is no horizontal asymptote. And then we introduced slant asymptote. Guys, listen. I'm talking. I did yesterday long division. I'll just real quick model, like if you wanted to do synthetic division. Remember, synthetic division would work if you were dividing by linear factors. So, in this reduced version, this is a quadratic divided by a linear. So I could set up synthetic, 1, 0, -2, and then I would divide by -1. So add down, multiply, add down, and I really don't even have to finish because this part is the remainder. And remember, I don't care about the remainder. So if you're using synthetic, this was x squared, so this is x and this is your number. And our slant asymptote is at y equals x minus 1. Okay. And that's the same result we got with long division. So if you're looking at that and you're like, yeah, I prefer synthetic, you can do it. I like long division on slant asymptotes because the x's just come in the answer. Okay, so I'm going to continue like what we would normally do for a rational function. And I always do like to check for intercepts because those are just extra points on my graphs, and they're easy to find. So for the y-intercept, I plug 0 in for x, so that would be -2/1. So I have a y-intercept at -2. And I'm plugging into my reduced function. And for the x-intercept, you can set the whole function equal to 0, but remember we also talked about in a rational function you really just need to set your numerator equal to 0. That's the only way the fraction would ever equal 0. So x squared minus 2 equals 0. X squared equals 2. X equals plus or minus the square root of 2. Okay. And I'll write that down here. I have plus or minus the square root of 2 common 0. Now, of course, if you're going to graph those x-intercepts, you have to think about the square root of 2. If you didn't have a calculator, you can still estimate where the square root of 2 is, right? It's more than the square root of 1, so it's more than 1, but it's less than the square root of 4, which is 2. So it's in between 1 and 2. I do know that it's like plus or minus 1.4. Okay. So let's put these things on a graph. Any questions about how I got my characteristics before I start graphing? Okay, so I'm going to plot my whole at -2, -2. I'm going to use blue. Left 2, down 2, whole. I'm going to do my vertical asymptote at x equals -1. Mark it as a dotted line. No horizontal asymptote, but I do need to graph a slant asymptote. So we should all be able to graph lines in y equals mx plus b. Plot your y-intercept, move with your slope. So my y-intercept is at -1, and then my slope is +1, so I'll go like up 1, right 1, down 1, left 1. There's my slanted line, y equals x minus 1. My scales are kind of off, so it doesn't look really good, but it's okay. Let's see. The intercepts, remember, those are just extra points. Sometimes you have them, sometimes you don't. So this is, I can plot my y-intercept at 0, -2. And I have an x-intercept at +1.40 and an x-intercept at -1.40. Now, if you decide that like those points and asymptotes aren't enough for you to figure out what the graph is doing, you should always make a table of values and pick more points. Okay, so you can pick as many points as you want. And they'll just like confirm what you think might be happening or what should be happening. 2 points in each of those sections is kind of all I need to know for me, because I also know that like the curves or the branches of my rational function, they get pulled towards the asymptotes. So like where my hole is, after I would cross this hole, I must be following this slant asymptote as it goes down. And then I would come up through my x-intercept, and then I must follow that vertical asymptote. So it's like a really stretched out curve. And then on the other side, I kind of have the same thing. Beyond the x-intercept, I must be following the slant asymptote, and then I can cross through my y-intercept, and then I must drop and get really close to my vertical asymptote. Okay. So I have graphed it with a slant asymptote. Now this one, we could do domain, and we actually can do range. So there's 2 ways for you guys to do domain. You can look at the graph and look for holes and vertical asymptotes, or if you want to do it purely algebraically, domain, you just have to look at what makes your denominator equal 0. So if I look at these 2 factors, x plus 1, x plus 2, there are 2 values that make my denominator equal 0, -2, -1. I have to exclude them, because I can't divide by 0. So pure algebraic domain, just set the denominator equal to 0 and solve for x. Or you can look at your graph. Those happen to be the vertical asymptote and the x-coordinate of your hole, -2 and -1. So you exclude them. So I would do -infinity to -2, in union with -2 to -1, in union with -1 to infinity. Okay. Now, listen very carefully to me. I'm speaking to each and every one of you right now, even though I'm not calling you by name. Sometimes with the slant asymptote, you wouldn't be able to do range without technology. So like it's possible that in these like skinnier sections of this X, I could have like U shapes that turn around and are trapped by the asymptotes. But it's hard for you to pinpoint when you have found the max or min of those U's. You could do that with your graphing calculator or a program like Desmos. If you take calculus, you'll learn how to find those max and mins using derivatives. Like right now, I'm going to ask you to do these things without calculators so I confirm that you understand the algebra parts. So sometimes I'll only ask you domain with a slant asymptote. Okay. On this one, I could actually ask you range. So I am going to ask you range. Notice, like, just look at this branch. It's just dropping, right? -infinity. So I'm just looking at my y's. I do notice trouble with my y right here because I have a hole at -2. But notice that was also my y-intercept, right? So I actually do have a y value of -2. I don't need to exclude the hole this time because it has a pair on the other side that's closed. And then this side just keeps going up, right? So we could say on this one, actually, the domain is -infinity to infinity. If you get a graph that looks something like this, you don't know what that gap is. So then I'm not going to ask you range. So just kind of be aware of that. Okay, questions? All right, I'm going to do one more example, and this is your personal choice. If you don't want to write this example down in your notes, if you're just like, I just need to like focus and see another example and watch it happen, this will be posted on my website, so if you decide you want to put it in your notes, you can. If you do want to copy it down, that's okay. But I wanted to do one that had 2 vertical asymptotes because we haven't seen that yet. And that's kind of like there's a weird thing that can happen when you have 2 vertical asymptotes. So if this were my function, f of x equals x cubed over x squared minus 9, I'd factor my denominator. But I have no common factors, so I have no whole. Move on to vertical asymptote. Because I didn't cancel either one of those factors, both factors become vertical asymptotes. So I have a vertical asymptote at -3 and a vertical asymptote at +3. Okay, horizontal asymptote, the degree of the numerator is 3, the degree of the denominator is 2. Does not exist, but Stone is telling me that's exactly one more, so I better check for my slant asymptote. This one, when I put x cubed in for my dividend, I don't have any other terms, but I'm going to put placeholders because, I like to line things up in division so I know when I'm done. And I can put the x squared minus 9 on the outside. So x cubed divided by x squared is x. Line it up. Okay. And then distribute. That's x cubed minus 9x, so see I'm lining it up with its like term. I don't put it under the x squared. And I'm subtracting both of those, so that's minus and a plus. And then the x cubes are gone. There are no x squareds, so I have 9x, and if you want to bring down your 0, you could. If you restarted the division, you'd be saying 9x divided by x squared, and there's not enough x's. So what that means is all of this you can't divide in again. So like there's really like a +0 up there. This is all part of your remainder. Okay, so this stuff is remainder. And remember, we don't care about that for slant asymptote. So our slant asymptote is just the line y equals x. Okay, now here's something interesting. If I do my y-intercept, I will be setting my x value equal to 0. In the numerator, I'll get 0. In the denominator, I'll get -9. And that's allowed, right? 0 divided by -9 is 0. So I have an y-intercept, which is also really my x-intercept. So if I set x cubed equal to 0, the answer is 0. But I have that at 0, 0. And what's going to be interesting in our graph is 0, 0 is a point on this slant asymptote. That's okay. So I'm going to draw that next. Okay, vertical asymptotes at -3 and 3. Okay, think about this. If you have 2 vertical asymptotes, you have 3 sections of your graph. So instead of having just 2 parts, you're probably going to have 3. Okay. And draw in my slant asymptote. That's the line y equals x. There. And like I was describing before, if I plot my y-intercept, which is allowed, 0 divided by -9 is an answer. Like that produces a point. It's okay to cross horizontal and slant asymptotes in the middle of your graph. Horizontal and slant asymptotes are really for the far ends of your graph, like the right side and the left side. So as I go to the right, I should be approaching the slant asymptote. As I go to the left, I should be approaching the slant asymptote. But I technically can cross it in the middle. It's about end behavior. And we haven't really seen that before. Okay, well, that's not a whole lot of points. I really don't know what's happening. So I'm going to make some x's and y's. I'm going to focus on the center part because I have that 0, 0. Let me put in 1. 1 cubed is 1. 1 squared minus 9 is negative 8. So that's going to be 1, negative 1/8. 2 is in there. I'll put in 2. 2 cubed is 8. 2 squared is 4 minus 9 is negative 5. Now, if you're doing this without a calculator, don't freak out. 8 divided by negative 5. You can get that in one time, but not two. So it's somewhere between negative 1 and negative 2. That's really all you need to know, right? All right, let me put in negative 1. Negative 1 cubed is negative 1. Negative 1 squared minus 8, that's 1 minus, or sorry, negative 1 squared minus 9, that's 1 minus 9, which is negative 8. So then that one becomes a positive 1/8. And we could probably guess this is going to be a positive 8/5. So what we're seeing here is something that looks kind of like a cubic graph, but it's constrained by these asymptotes. When you have two vertical asymptotes, you can have this, I'll call it a bendy graph, like a cubic, and it could be increasing. You can also have U's that open down or U's that open up in between the two asymptotes. You really don't know what the picture is until you pick the points. All right, and then finally to finish this one up, I really need some other x's and y's because I've never plotted a point left of the vertical asymptote or right of the vertical asymptote. So I'll choose negative 4 and just see where is my point. If I put negative 4 in, I get negative 64. That would be positive 16 minus 9, which is divide by 7. Again, without a calculator, you can figure out about where this point is, right? Negative 64 divided by 7. Well, negative 64 divided by 8 would be negative 8, so it's a little bit more than that. So all I know is that I'm going left 4 and down 8. It's stuck in this little V, so I'm going to have to turn around. And this is one of those, like, you don't know where the turn is, and that's okay. But you know that it exists down there. And then if I put 4 in, that would be 64 over positive 7. So that would mean I would go right 4 and up. And that one's trapped by these two. So you can have two vertical asymptotes. This one's with a slant asymptote. You can have two vertical asymptotes with a horizontal asymptote in there. So then they look more like the branches we've seen previously than those weird U's. But you'll have 3 parts to your graph. Okay. You could do domain and range. Domain, you would restrict negative 3 and 3. Range, because that middle section would be all real numbers again. There's no issues. Okay? Your homework is to finish the blue sheet. So find your blue sheet.